the outline, yeah, it's going to be mostly the resource allocation competition. I'll do the usual updates on some of the outages and maintenance that we've had, introduce Beluga, and then the user training. I thought, however, just for a little bit of fun, initially I was just reading about all the efforts now in the United States and in China to build the next generation of supercomputers, exascale, exaflop systems. And I was just reading about this, the Coral 2 procurement from the Department of Energy, and they're going to build something called Frontier at the Oak Ridge National Lab. They're aiming to get it up and running in 2021, 600 million. So that's a bit more than Canada can afford, but not too bad when you consider the difference in populations. And it's going to be an AMD machine with a Cray interconnect. So that's kind of interesting that AMD has been very successful with their new very high numbers of cores in their CPUs. And their GPUs too. They're beginning to compete with NVIDIA, which is actually really good news for all of us, because NVIDIA has had the GPU market kind of sewn up, and GPUs are really expensive. So hopefully with a bit of real competition, we'll see some of those prices come down. The part that kind of blew me away was the 300 kilowatt per cabinet. So one rack, 300 kilowatts. We're lucky if we can get 30 kilowatts now, and a 40 megawatt system. That's just amazing. And I suspect they won't actually get 300 kilowatts per channel, per cabinet. That's getting kind of extreme. But nevertheless, this is going to, and for the kind of exaflop end of things, this is actually really good. This is better than most when it comes to the power draw per megawatt. So anyhow, kind of fun stuff to start off with that we're seeing this. Oh, and I should note, of course, there's intense competition between the Chinese, who have said they're going to have an exascale system 2020 or 2021, and Japan too, working hard on with Fujitsu, developing their stuff. So I think it's going to be pretty exciting in the next year or two to see where these guys come and how they develop these new systems. And if we're lucky, a few years down the line, we'll be able to piggyback and see if we can upgrade all our systems and use some of the stuff that these guys are going to be developing. Anyhow, so little aside there, but off to RAC, the Resource Allocation Competition. So you know we do this every year, and I think I've done this particular town hall for something like 3 years now, where we try to go over the RAC results and talk about where we are in the high-performance computing end of things within Compute Canada and on the national scale. And it just keeps getting bigger and bigger every year we do this. So we got the highest number of applications in RAC history, 507 projects, about 8% more than we had last year. And then come those 4 bullet points, which are just getting worse and worse. So we were able to satisfy something like 41% of the total CPUs cores requested. So that's down from last year, which was 44%, something like that. Storage, 86% we managed to, of the total storage requested, we satisfied, we allocated. This is very worrying to me. I think it's the first year where we started banging up against our storage limits. We have in previous years worked with users, tried to make sure that users offload stuff onto tape, try to economize on their storage, don't keep things they don't need, all that kind of thing. And this year, even with the immense amounts of new storage we've got, something like 90 petabytes now, we've seen the storage demands just go through the roof. So yeah, we were able to satisfy pretty much everything. Not too bad. In particular, the SFU Cedar guys installed 10 petabytes of new store, which kind of saved us. But storage is now going to be a real issue. The GPUs, the third bullet point there, only 20%. So GPUs are still really bad. We are seeing a huge uptick in requirements for GPUs. And I did an analysis last last summer of the RAC 2018, and almost all this is from projects who are using machine learning as a component of the project. They're not researching into machine learning. They're just using machine learning. It's become a production item. So lots and lots of folks want to work on GPUs. I've got some notes about that in a little while. And on the cloud, the fourth bullet point, the cloud is still pretty good. Did have some storage issues, and that's up in that 86%. But fortunately, last year, with the CFI infrastructure funding, we were able to buy quite a lot more cloud storage, and so the cloud is in pretty good shape. The 95% of the CPUs requested, we were able to allocate. But again, we can see that those graphs are increasing as we go along. And I'm strongly involved with the whole RAC end of things. We have a technical review phase when technical reviewers look through every application, and they don't actually rate the applications, but they do try to identify places where we could help, where we want to reach out, where we think that the requests are maybe not justified, or that sometimes they need more than they've requested, and we pass that on to the full RAC review board. So I read quite a few of these. In fact, I read all the WestGrid ones and have a look at quite a lot of the other ones through chairing the technical review operation. And I'm always blown away by the very high quality. We have been working with researchers now for many years, and I think, as you may know, in WestGrid, we spend quite a lot of September doing site visits, working directly with researchers, reading proposals as they come through, making comments and such, and there really aren't too many poor ones anymore. But with the resource crunch that we've got, submissions really have to be really good for you to get what you asked for. So it's a very intense process of science and technical reviews, and my dogs don't like that. But and I just note that this is a big process too. We end up with about 80 science reviewers who actually do the science review, and that's in various subcommittees who work through it, and then we meet in February, usually face to face, where we get all the chairs of each of the subcommittees together, and we end up with a rating. Yeah, so again, a real problem this year. As usual, we with the increase in the requests and not a sufficient increase in the amount of resources we've got. And I think Lindsay asked me to note that institutional reports giving details are sent to each VPR, and I think they've just gone out. Here is the RAC history. There's on the right-hand side the 507 this year, and you can see the increase as we're going along, sort of 18%, 15% as we go up per year, and pretty consistent linear increase. And I think we're all pretty much aware of that computing, in particular big computing, is becoming much more a commodity item for research projects. Even sometimes the weirdest little research projects have got a machine learning component and are just getting well beyond what a laptop or desktop can provide. So I don't expect to see this level off at all. I think it's going to keep going, and we'll just see more and more requests for big compute. So here's a quick look at the actual allocations themselves. So in Compute Canada at the moment, we've got the four compute systems. This does not include the cloud. So Beluga in Quebec, Cedar at SFU, Graham at Waterloo, and Niagara in Toronto. And Beluga, Cedar, and Graham are general purpose machines. So they're pretty broadly based, so essentially anybody can use them, and they're not really focused. While Niagara itself is focused on very large parallel systems. So Niagara's quite a lot simpler than the other ones. Niagara, for instance, does not have GPUs, but Graham, Cedar, and Beluga do. So there gives you some idea of the capacity under the supply column. And there's our request and how much we allocated on each machine and allocated over the requested. There's that 40%, the 41%, 42% coming out. We do, during the RAC admin meetings, try to balance demand. So if we see an awful lot of requests for Graham, we might move them to Cedar. We do our best to keep them on the machines that users are already familiar with. Because it can be quite disruptive if we move something from one machine to another machine, and the users have to then change some of their stuff. Now, with the advent of the modern systems, the newest systems, they're all pretty much identical, use the same software stack, all that kind of thing. So it's not a huge effort, but you still, especially if you've got big databases that one's been using, and you have to move those databases back and forth between machines, it's a bit of a pain. So we do try to keep them on the machine you started from. And that's more or less the reason why Beluga, if you look at the percent allocated, the last column, we've allocated about 70% of Beluga. But Beluga just came online in the beginning of April. This is the first year it's been around, so nobody was on it. So there were Quebec users who were moving from the old legacy machines, and some of our users who have moved over to Beluga. But generally, we've kept that down a bit. So there's some room in Beluga for all our default users. And just to remind everyone, we try to keep about 20% of our resources unallocated, and that's for all the new researchers, the smaller projects, all the rest. And that's the Rapid Access Service, the RAS. So we call it the RAS, or the default. So you can see Beluga's got a little more room for all those other users who did not get an allocation. And for the rest, Cedar and Graham, well, a bit higher than 80%. And Niagara, being a large parallel and aimed very specifically at very large jobs, that we allow ourselves to allocate higher than the 80%. It's at 94%. That's actually maybe a little high, but we had quite a few requests for Niagara kinds of resources. So total 84%. Yeah, it's not 80%, but we're not too far off. We always end up being a little more. So that's 16% that's left. So that's for our default users and for anything special that comes up. It's our cushion. And indeed, we get out of rounds, new researchers coming in, those kinds of things where somebody needs a bit extra resources, and we can use, well, we're very conservative because these new default, or all these default users, they need some resources too. And they're building, usually new researchers who are building up their reputations. So we are very careful about that 16%, but there it is, gives you some idea of what we've ended up with. I think overall this is actually a little better than previous years where we've been inclined to allocate more than 84%. Couple of notes. Beluga is included in RAC this year, and I think almost all the legacy systems have now gone. So we had a few last year that kept going, Orsinus, for instance, in WestGrid. But those have all gone now.
Patrick, we've got one question in the chat regarding growth in demand versus forecast.
I see that, yeah. How does the actual increase compare to the forecast? Let's see, I'm trying to remember some of those numbers that we had a couple of years ago. I think we're, in practice, a little under the growth, the actual growth. And in those analyses, that was 3 years ago, I think, the last big ones we did. We went out to the scientific community. So we went out to the chemists, to the astronomers, to each of these communities, and asked them what they thought overall their kinds of demands would be. And if I recall, they were a little more exponential than this linear growth that we've actually seen. Yeah. So I think we're not doing bad, but of course we didn't get enough money to actually get anywhere near what we were predicting the demand would be. I didn't want that to say too negative. We did get the cyber infrastructure funds and the money, so I mean this was a great thing. We absolutely had to replace our existing kind of old capacity, and the government and CFI stepped in to work on that one. But yeah, not really enough. I'll have more to say about that in a minute because I mean there's some really good news on that end of things. Here are CPU allocation trends, and there's that 40% from the top of the red line down to the supply and how much we actually allocated in the end. So yeah, we're seeing this increase on straight CPU. This is not storage, not cloud stuff. Yeah, a bit of a jump this year, but I don't know if that's in the noise or not. We'll see in the next couple of years how it's going. And you can see that the supply, well, we bought some good stuff back in 2011, 2012. That was the last real purchase. And in here, 2016, 2017, 2018, that's when we started to defund the old systems and buy the new systems. Now, I want to note this is straight cores, and we have not attempted to estimate the difference in performance between an old core, one of the old Intel chips, and a new core. And there's a big difference. In some cases, we are seeing speed ups between old and new of 4 or 5. I have to say, in other cases, we have actually seen slowdowns. That is probably due to the memory bandwidth per core. As we see a very large number of cores per chip, the memory bandwidth, while it has also gone up, it has not gone up as much. So if there's a lot of interconnect traffic, sometimes the new cores are not going as fast. But certainly I think on average probably the new cores are 50% or 100% twice as fast. So this kind of graph doesn't show that. This is straight number of cores that we've got. And I think we've had some of the new machines now for a year and a half, so we're beginning to see that and this is kind of my informal look at things, is that the users are still using the same number of cores. They're just making them do more things. That not only have the capability of the hardware gone up, but so have the demands of an individual job. So we're kind of seeing go neck and neck. So we still need more cores. There's the whole GPU issue. And you can see Beluga, Cedar, and Graham are the ones with GPUs, and they're in the supply column. We have a number of GPU nodes with GPUs. One can schedule onto those nodes. There are the requests, huge, and how much we allocated, and the requested over allocated. Yeah, requested over allocated. So Cedar and Graham, just everybody wants GPUs, and I have to say that is one of the most painful parts of the February face-to-face meeting, and a few of us get together, and I'm afraid we just end up cutting and slashing, because you can't sort of automatically cut by a factor of 5 or 6 or 7 the requests, and it's very tough. We look at each one, look at the scores, look at each proposal, and try to figure out what they could really do with. In the little pink box at the bottom, I just note that for instance, a Cedar GPU node costs about 5 times as much as a standard CPU node. So usually one can use CPU nodes if you don't have GPUs. You can just use more cores. And we've seen this. We try to look at this kind of thing as best we can, although it is a very wide range. But if you can do it, it may be actually cheaper to use more CPUs, just straight cores, rather than use those very expensive GPU nodes. And that comes back to this business that Intel's had the market all by itself. Putting a few of these voltas or pascals on a node is really expensive. And it shows, there's the financial value, and this is our estimate of the total cost, including operating costs, for us to provide a core year, $121, or a GPU year, $2,400. Huge. So the point here, I think, is that yeah, if you feel you could use CPUs and just use a lot more CPUs, that's almost a good idea. You can get that to work rather than trying to get GPUs. Let's see, and Beluga's new, so we don't have too many direct asks yet. We again tried to balance all that. And it's also a little difficult just to note that Cedar and Graham have Pascal GPUs, and Beluga has the new Voltas, which are rather more powerful. So we work together on that kind of thing. I should note that the Beluga team, McGill, did a brilliant job of trying to see if it was worthwhile buying those new Voltas, which are much more expensive, or the older Pascals. And they looked at a whole range of applications, and they came out thinking that the new Voltas were in fact a little more cost, a little higher cost benefit than the less performant Pascals. So they ended up buying the Voltas. So those are that 688 Voltas there. And I guess we're learning, we've only had the thing go up and running for a month or so, so we'll be learning a lot more over the next year as to how efficiently one can use those. There are the allocation trends, and this one is looking a little more for GPUs, and this one is looking a little more exponential in the way GPUs requests are just blowing through the roof. Yeah, so there's the big gap between the red and the yellow of how much we've actually been able to provide. So storage allocations, as I mentioned, this is the first year where initially we really thought we wouldn't have enough storage, but had to go back and look through things, and we bought some new storage, so it kind of saved us this year. But I think we're going to have issues next year on allocating storage, and we're going to have to go back to a lot of users. Storage, we do not scale. We can't sort of say, you know, somebody asked for 100 terabytes, and you got a really poor science score. And really poor in this context means not excellent, because the cutoffs are so high. And then we say, well, you only get 20 terabytes. Well, if you need 100 terabytes for whatever data sets you got, 20 terabytes don't work. So we do ask in the rack process for you to tell us about the storage, what you could get away with, and what the issues would be if we cut it down. So we look at all that and try to figure out what we can allocate. This year we're good. We pretty much allocated everything. And but I think we may have project problems next year, and there's no easy way of handling storage. I will note that Compute Canada is undertaking a major review of the whole rack process. We're wondering if we've got it right. We're working, you know, the fundamental problem is lack of resources, but at least try to be as fair as we possibly can. I doubt that we will see any big changes next year for RAC 2020. I think you can expect RAC 2020 to be pretty much the same as this year. But the year after, we might be looking at different processes. So there will be a process for input from users and researchers into some analysis of that. And project, and then the storage, I think, is going to be a big one there. So some of the details. Oh, I should say, if you got any ideas or you just want to make some suggestions, feel free to send them to me. I will include them in at least some of the. We're very preliminary right now, but it'll increase. The whole effort will increase when we start looking at these new ways of doing rack. Right, we have 4 kinds of storage project, and that's the project-based one that we actually allocate. Dcache is specialized stuff for the Large Hadron Collider and the Atlas guys. We have cloud storage, and nearline is tape storage, which I've got another slide about that. We haven't quite got going yet. but that's for the essentially static data. Anything that we can offload from the online project storage and get it onto tape is a good idea. So gives you some idea, allocated over the need. The last column, 76% for project. Dcache, the special projects are using a lot too. Cloud up around 80%, and nearline, yeah, 96%. We've actually allocated most of our standard capacity through the number of tapes that we've got around. And notice these numbers are in petabytes, right? 32, well, they're in terabytes, but 32,500 terabytes, that's 32 petabytes. So this is pretty big requirements when it comes to management, the tape drives, how fast we can get data onto the tapes. There are lots and lots of bottlenecks in working with tape. And these huge shared file systems, the project space, this is a single point of failure for our big systems. If the shared file system that handles these very large disk systems fails, then fundamentally the system goes down. Of course, it's highly redundant with multiple controllers. You know, we can lose disks, we can lose whole nodes, and in theory, this whole thing stays up. But nevertheless, I think the biggest headache we've got in running any of these systems is these storage systems. So when I see numbers like project 76%, well, fortunately people don't use it, but getting up to 80 or 90%, and this really starts to cause issues with the storage system. It just doesn't have enough overhead space to work well. So we're really getting into that. I am a bit worried about next year. Compute Canada estimates the financial value of these awards, and that is, and in the award letters, we tell recipients the value of what they got, and that they can use, of course, for other grant applications and for performance reviews and such. So these numbers are kind of averaged. For instance, a GPU year is an average of the voltas and the pascals, but it does include operating costs and power and such as best we can. Try to estimate how much it costs us to provide 1 core year of compute. $121. So not too bad. Rather interestingly, I think it was just the day before yesterday, I went to Amazon and had a very quick look at what an Amazon compute node would cost. And that came out to US $372 per core year. So we're essentially a third of the basic Amazon cost. And those costs on Amazon do not include things like storage or network costs. And remember that now this is a very rough comparison because Amazon has special ways of getting cheap pricing, the spot market, and it's on demand. So if you don't use it, you don't get charged for it. So a lot of things that, mind you, our systems are going 100% all the time. So you know, there's always something in the queue, but it gives you some idea. And of course, what's happening is that we are leveraging a lot of the existing infrastructure. The data centers are at universities. The universities have usually pretty good access to power and such, and a lot of the capital costs are sunk costs which we don't have. Plus, I should say that we don't have huge staffs, and Amazon has an immense infrastructure and management operation to keep it going, and they are, I think it's very fair to say, quite a lot more reliable than we are. Oh yeah, okay. I see. There's a note about saying 2 cores for C5 is kind of a lie. If your core doesn't use hyperthreading, it's 1 core. Yeah, absolutely. You can go back and forth and try to get these numbers, it's kind of hard to be precise. So I really want to emphasize that's a very rough number, but at least it gives some idea that I think we are very cheap and doing it pretty well right now, leveraging the kinds of resources that Canada already has to keep these costs down as much as possible. Yeah, GPU year 2400. There's that difference. It's a GPU is expensive. Terabyte of storage. We're pretty good on a terabyte of storage. Amazon is actually pretty expensive. I don't know if anybody's used Amazon storage. That's the block storage there. Oh yeah, Nathan, did you just put the comment that you have a full comparison? I'd really like to see that. Cool. Okay. Yeah. Can you? Well, send me an email, patrick.mann@westgrid.ca, because I would really like to see that. Okay. Yep. Excellent. Yeah, because what I did was just yesterday, just grabbed a few of the numbers, and yeah, cool. Yep. Okay. Barton's from Cybera, so he's also asked that if you can distribute that, that'd be really well worthwhile. Okay, there we are in a virtual CPU year using OpenStack on the Ceph on the Arbutus cloud at UVic, $81, and storage there is a bit less expensive, 118, but pretty much the same, and it's the same kind of hardware on the cloud. Although, as usual, the cloud has to do some replication and such of data, so it ends up using more. Anyhow. Interesting points there, I think, in it, and especially seeing what Nathan you've got there, is that I'd like to do a bit more of an analysis. We did, I think, Compute Canada did analysis a few years ago and came up with similar kinds of numbers between what Amazon and other cloud providers could give, getting factors of 3, 4, or 5. But I think we should redo that as best we can. It's always very tempting to burst out into Amazon or Google Cloud or Azure, but at the moment it's kind of tough to do that. It's expensive. We prefer to purchase our own hardware if we had the money. Just one point here, yeah, if you got one, there's the introduction for those for new users out there about how to use your resource allocation. And that's the docs wiki, docs.computecanada.ca. That's where all the new Compute Canada docs are, and there's a lot of good information there. So yeah, head there if you want to learn more. This slide is the sort of good news. You might remember that a year ago, the federal government announced $572.5 million, $500 million for digital research infrastructure. This was brilliant, and the planning around that is happening, but unfortunately I can't say too much about it because some of it hasn't actually been announced. But the DRI funding was announced in spring 2018. There's an analysis last year of requirements. ICED is worked through a lot of the stuff, a lot of consultation, and they announced a competition to set up a separate organization which would handle this $500 million or so. And there are lots of details in there as to who gets funded with what and what's involved in the new organization. A proposal from universities, from the U15, went in only on Monday, so last Monday. And if you want to see what it looked like and all the rest, you can go to those websites. So this is great. And Compute Canada made quite a big proposal last year for what we call bridge funding. We looked at that 40% and the 50% and the lack of GPUs and all that kind of stuff, and said it's going to take a couple of years, 3 years at least, before we could start spending this $572 million. I should note Canary's in there, so it's not all ours, but for digital research infrastructure. And so we could do with some extra funds nowish, like as soon as possible, just because we are so skint for resources. So that did go in, and the news is actually pretty good, but I can't say much more than that because we haven't had any formal announcement yet from ISED. So I really hope we might have a few more resources next year to cover some of this shortfall. Sorry, I can't be more precise. Right. So, good. Okay, yeah, and I see. Oh, Nathan, you gave us. I see you've added your email address. So if anybody, I guess you'll respond if anybody else wants to see your numbers. That's great. Good. Okay, so there was RAC. Some idea of where we are, where we're going, and as usual, I think the RAC 2020 announcement will come out later on in August. And you'll have September and October to create the new proposals and send them in. And then we'll be doing the technical reviews in December and working through the whole process again come next January and February. So keep an eye out for that and do the new RAC. Right, I'm going to go through this pretty quickly here. Because I'd spent some time on the RAC. Outages and maintenance. Graham had a couple of outages. Again, there's those file system issues. Those are the ones that drive us nuts. The big file systems, the Lustre file system, runs with metadata, which keeps track of where all the files are. And then there's the actual storage devices. And the metadata server, and when you start asking for 1 million files or running jobs, which dump tons of small files, the metadata server can get kind of hammered and slow down. So they had to do some things there. They had a internet partial outage. Every now and again we have internet outages. They don't stop the machine, just means you can't contact them sometimes. Cedar, we've just undertaken a major outage, and again, I've got an extra slide about that. There were some issues with it, but you can see the last three, the April 12th, March 21st, and 13th stuff. Again, it's all file system issues. Those big Lustre file systems are tough to keep going. They are community projects. Lustre is not a commercial product. And there just aren't that many Lustre installations in the world. There are thousands probably, but they don't find all the bugs. So we find the bugs. Everybody finds bugs. So that was great. I just note too, back in March 1st, there was another major upgrade on Cedar, and they replaced the SSDs for project metadata, and that's really improved things, I think, quite a lot. We're not seeing a lot of the slowdowns and issues that we were seeing last year. The SSDs are much faster, and they're handling some of these metadata issues. They're top Beluga, yeah, Beluga's up and running. And guess what? It's also having some storage issues as it goes along, as they're learning more. And of course, it's now under full production mode, so people are hammering it, and a few little bits and pieces are coming up. Arbutus again a couple of weeks ago, had another file system issue. Arbutus uses the Ceph operation, and usually that goes really well. Ceph is pretty solid nowadays. That's the object store from the OpenStack cloud software. And in that case, that was kind of just one of those little gotchas that just seems to happen every now and again. They had upgraded the Ceph version and then added a new Ceph node, a new storage node. And I/O stopped on some nodes, and file systems went read-only, and they wouldn't boot, and that was a real problem. The issue turned out to be a slight change in the default configuration in the new Ceph version. So it's kind of interesting that rather small changes that are deep down in the thousands of Ceph configurations can cause us some issues. The UVic site team there found the error very quickly and fixed it up, and of course changed the configuration. And then back in March, top of rack network switch, we do have hardware failures occasionally. Just that Cedar April 29th one a couple of weeks ago, again, so much of it aimed very much at the shared file systems. DDN is Data Direct Networks. They're a major supplier of hardware for many of the big supercomputer centers, and then SFA14K is the system that we've bought from them. They had to do some firmware updates. There had been some stability problems on Scratch, and I think folks, we had quite a few complaints that Scratch was slowing down, not working, and causing jobs to fail. Along the way, the operating system and Lustre on /project was updated, and there was a bug in there that needed. Plus OmniPath, and remember OmniPath is the interconnect on Cedar, and that was kind of, they had already updated to a new version, which turned out for some kinds of jobs to slow the whole thing down hugely, like factors of 4 or 5. So that was a nasty one, but again, turned out to be a little thing that Intel, in this case, they had introduced into the OmniPath drivers, and that's now fixed. Yeah, and I've just got some notes at the bottom. Some issues, electrical work they were doing took a little longer. The firmware update, some of the nodes all forgot their configuration, had to be redeployed, and some issues with the GPU drivers. But those were all fixed on Tuesday, just after the outage. There's the nearline stuff. I already mentioned that. I just want to note that nearline, the issue we're having is that when we move storage or data, your data, from online, usually /project, to tape, well, we don't want to keep only one tape copy. We're always a little paranoid about tape. So the nearline will keep 2 geographically distributed tape copies. So right now, Graham is in production, and their nearline system is copied onto Cedar tape drive. So we've got 2 copies, and Beluga and Cedar, that's what we're waiting for. Both of them can do the nearline, but we haven't got the site-to-site copy yet. So hopefully this will happen pretty quickly. And particularly for Cedar, they were waiting for the April 29th updates to get finished before starting to work on the site-to-site tape copy. So I really hope we'll have this available to folks in the next month or so. We've been saying this for over a year now, but got my fingers crossed. Quick usual reminder, Orsinus was defunded on March 31st at UBC, but UBC is keeping Orsinus going for a couple of months, but you should, if you're on Orsinus, please make sure your data gets copied over to, for instance, Cedar or Graham or Beluga. And there's contact if you want help on doing that. So Orsinus is no longer a WestGrid system or Compute Canada system. It's I think UBC is going to keep it going, but if you want more, ask Roman. And there's a whole bunch of links to Beluga. The opening ceremony was April 26th, but it went into production April 3rd in time for RAC. And real congratulations to the Calco Quebec team. They've done a brilliant job and had lots of issues with the supplier and some tests that were not passed. It's a Dell system. And then they had to go back and a lot of back and forth. So they ended up being, I don't know, a couple of months late in just getting Beluga, but still managed to get it up and running. So really a brilliant job. Let's see, renewals are happening right now. And remember, that's the business where every year we ask each user to renew their account to tell us they're still there, still working. As of this week, a couple of days ago, the unrenewed accounts, the deadline was Monday, are being deactivated. So we're seeing a number of support messages coming in from users who forgot to renew their accounts. Please do so. And the one issue, just in that pink underneath there, is that if a principal investigator, a project lead, fails to renew, then the whole project is deactivated, including sponsored users. So one of the things I've seen this morning and yesterday is a number of requests from team members, like grad students and postdocs, saying, I just got deactivated. You might want to check if that's if you have renewed and you still get deactivated, you might want to check with your supervisor or PI that they actually remembered to renew their account. Very quick here. These are just a few notes that have come up in the last month or so with new Beluga and such. I've mentioned it before. The GPUs, they're different. Cedar has 4 pascals per node. Graham has 2 pascals per node, and Beluga has 4 voltas per node. So you might want to play around with those a little bit and see which one gives you the best performance. We had some queries for some reason about node connections to the internet. I think some licensing stuff. Cedar allows that. You can connect from each node to the internet, but Graham, Beluga, and Niagara do not allow direct connection from the node to the internet. They only connect to the head node. So if you want to get those, you'll have to ask at support@computecanada.ca. Interconnects, again, there seem to have been a couple of questions. Cedar's got the Intel OmniPath interconnects, and the rest are InfiniBand. Oh, and the next one, running jobs from /home. Actually, Cedar got kind of overwhelmed. A lot of people were running jobs from /home, which remember is just a small place for you to keep scripts and codes and such. And that was actually overwhelming /home. So there was kind of a sudden switch where the Cedar guys decided they really couldn't allow that. So I just noted here that you're supposed to run jobs from scratch or project and not from /home, and right now you're not allowed to. Status pages, and this is a note here that we were keeping the WestGrid status pages up to date, but we are no longer doing so. All the old machines have gone. So I think if you look there, you'll still see a status page, but it's not up to date. Go to the Compute Canada status pages. Let's see, we've hired some summer students, and we've got a new junior developer joining us. So this is aimed at the research platforms and portals, the RPP folks who are developing their own scientific gateways. So we've got some expertise. They're already working on some. I've got a note there about what we're working on. If you want to come and talk to me, if you've got a project that might be that you might want a little help on developing the gateway, the databases, that kind of thing, the GUI, the front end. We've got some expertise which might be able to help. Right. At this point, I'll just hand over to Alex for a few minutes to tell us about user training.
Okay. Thank you, Patrick. Yeah, that should not take more than a few minutes. I have just a few slides. So I will start with the online training. As you probably know, we have been running the online webinar sessions for the past few seasons, and the winter and spring semester is almost over. So this year we had 8 webinars on a variety of topics. So all of these are archived with slides and video at the following website. So that's our training wiki, our training materials page. And we have only one webinar left this session, so that's going to happen next week, next Wednesday, May 15th. And it's going to be on using Twitter APIs to mine data. So these webinars happen every 2 weeks at the following times. And we're now thinking about the topics for the fall webinars. So if you have any suggestions, please send these to us. Send an email to info@westgrid.ca, and we would love to have a variety of topics, so similar to this year, this term. And yeah, so please send us an email with any requests. Next slide, please. We have 2 summer schools this year, as in the previous years. So last week of May, we're going to have a summer school at the University of Calgary. So that registration for the Calgary school was open for quite a while now, and we are full currently. There's a waiting list, so if you are registered already, then you can get into the sessions, no problem. If you are on the waiting list, we're going to be releasing a few more seats, maybe a few dozen more seats, depending on the per session interest, next week or the following week. So if you are thinking about registering, please make sure you get on the waiting list, because people on the waiting list will be sent email invites. And then we have a summer school at UBC the last week of June. So for that one, we just opened registration. Currently, there are lots of spots. And both summer schools, they have a large variety of courses, so HPC, Introduction to Linux, machine learning sessions from outside instructors, from MATLAB, from Amazon at UBC. So please check the web pages. They're linked right on the slide. And they're also linked from the training materials page. Next slide, please. And this is our training materials page that's been around for probably a year and a half now. So there we archive all our training slides, so the recordings of the webinars, sessions from the summer schools and other online, offline events, in-person events. So if you haven't seen it out, did it all the time. So since the last town hall, we added quite a few webinars. And if you explore this, so the main menu is at the top. If you go to domains, there will be pages in the submenu for bioinformatics, digital humanities, molecular dynamics, astrophysics tools. We have visualization, cloud scheduling, and research data management. So a lot of material there, including the getting started pages and programming guides for various languages and libraries. So please check this out. And I think I will pass it back to Patrick. This is my last slide.
Yeah, thanks, Alex. Yeah. So lots of things going on there. I'm just going to pick up on one thing on that last slide. In the recently added, it's managing many files with the DAR disk archiver, and I just want to note that all these issues with the shared file systems, a biggest issue is writing and reading a whole bunch of small files. These distributed files just don't handle that well at all. They're just not designed around that. And DAR, I listened in on Alex's really very useful webinar. I think that's a very useful way of taking tons of small files and putting them into one big file in a way that's far more flexible than the old Linux tar approach. So I don't know, Alex. I just thought I'd mention it that yeah, there's something really I really like that, and I've begun using it myself. Okay, I think whoops, wrong way. Yeah, there's the questions again, and you can always mail us at support@westgrid.ca and or support@computecanada.ca. They all end up coming to us. So I think we're done. Thank you everybody for joining in, and we'll see you at the next town hall.